Beautiful moment we have. What a beautiful moment we have. We'll be looking at cooperativity at first. Okay, the definition of cooperativity, and we said if one or more, if more than one ligands, is that okay? If more than one ligand binding site is present on a protein, we said there is a possibility of interaction. Between the binding sites during the binding process. Full stop. And we said this is known as cooperativity. When there is an interaction between ligands and the binding site of a protein, this is known as what? Cooperativity. And then we go to the next question that says, what are the four major types of cooperativity? The four major types of cooperativity. Four major types of cooperativity that we have. Number one, we have positive cooperativity. What do you mean by positive cooperativity? Of course, this is said to occur. Is that okay? When the binding site or the binding of one molecule of a substrate, is that okay? The binding of one molecule of a substrate of ligands increases, emphasis on increases, is that okay? The affinity increases the affinity of the protein. For what? For other molecules. Of the same or different substrates or ligands. That is what we understand by positive cooperativity. So positive cooperativity occurs when the binding of one molecule of a substrate increases affinity. The word affinity can be likened or is similar to the word love. So increases the affinity of protein for other molecule of the same or different substrate. Now we have another terminology that we want to look at. We want to talk about negative cooperativity. This happens when the binding of one molecule, is that okay, of a substrate, when the binding of one molecule of a substrate of ligands decreases. Now one is increases, the other is decreases. Is that okay? Decreases the affinity of proteins of the protein. Increases the affinity of the protein for other molecules of the same or different different substrates or ligands. Is that okay? That's positive cooperativity and negative cooperativity. The next we have, number 3, is what we call homotropic cooperativity. Homotropic cooperativity. What does this mean? This occurs when the binding of one molecule of a substrate, or ligands affects. Did you see that? Emphasis on affects. Affects. Is that okay? The binding affects the binding to the protein. Affect the binding to the protein. Is that okay? Of subsequent molecule. Subsequent molecule of the same substrate. Or ligands. That's what we understand by homotropic cooperativity. Then for the last one, we have something called heterotrophic cooperativity. Heterotrophic cooperativity. What do we understand by heterotrophic cooperativity? This occurs when the binding, is that okay, of one molecule, of a substrate, is that okay, or ligand affects the binding, so I'm putting that in a very simple term, to the protein, affect the binding to the protein of molecules of a different substrate or ligands. That's okay. That's beautiful. That's very, very interesting. And you find out that the Hill's plot is one of the things you can use to determine cooperativity. So in the Hill's plot, is that okay? We are plotting y over 1 minus y against the log of s. Okay, the log of this against the log of the substrate concentration at fixed, you see, at fixed proteins, at fixed protein concentration. Is that okay? So those are the things I want to highlight about cooperativity. All right, then the next we have, so we move to topic 2, where we have, what do you understand by single substrate enzymatic reaction? We said this refers to the reaction where there is a single substrate, is that okay, reacting with single enzyme molecule, forming an ES, and afterwards the ES means, in biochemistry, the ES means enzyme substrate complex. That's what it means. Is that okay? So the ES is being converted to products. That is why, of course, it's called single substrate enzymatic reaction. Is that okay? We move to the next question is, what do you understand by the multi-substrate enzyme reaction? And we said this refers to a reaction where multiple substrates, emphasis on multiple substrates, binds to the ES complex. So let's assume that this is the ES complex. Multiple substrates are binding to this. multiple substrates are binding to this, thereby yielding multiple products. Multiple products. That is what we call MSCR, also known as the multi-substrate enzyme reaction. And so, in the multi-substrate enzyme reaction, the ternary complex, note that in MSCR, the ternary complex, is that okay? The ternary complex, consists of enzymes and two or more substrates. It always consists of enzymes and what? And two or more substrates. Consists of enzymes and two or more substrates. So in reality, you now begin to find out that many or most common enzymes are those that catalyze two substrates. The most common enzymes are enzymes that catalyze two substrates and yield two products. For example, we have alcohol dehydrogenase. That's a very, very classical example of multi-substrate enzymatic reaction. Alcohol dehydrogenase. And what we found out is that the rarest are those enzymes that catalyze 3 or 4 substrates and yield multiple products, right? There are enzymes that can catalyze two substrates and yield two products. That's okay. Example is this man, which is what? Alcohol dehydrogenase. That is why we said in MSCR, a reaction where multiple substrates bind to the enzyme complex and yield multiple products is MSCR. A classical example is alcohol dehydrogenase. It's an enzyme that exhibits MSCR, multi-substrate enzymatic reaction. Is that okay? Alcohol dehydrogenase, right? And we also have enzymes that can catalyze 3 or 4 substrates and yield multiple products. E.g., some enzymes can catalyze 3 or 4 multiple substrates. Is that okay? Can catalyze 3 or 4 multiple substrates and yield products. Yes, they can yield products. E.g., an example of that is what we call glyceraldehyde glyceraldehyde 3-phosphate dehydrogenase. Glyceraldehyde 3-phosphate dehydrogenase. This is a very interesting example of an enzyme that can catalyze 3 or 4 multiple substrates and yield product at the same time. So now this is where the big picture. All right. The big picture we want to look at is MSCR, as it were, multi-substrate enzymatic reaction, is broken down into 2 major categories. The 2 major categories that we have is what we call the sequential mechanism. This is where I want you to pay full attention. The sequential mechanism, and what we have as the non-sequential mechanism. All right. So when you have sequential mechanism and non-sequential mechanism, what does this entail? So let me explain quickly. In the sequential mechanism, what we understand is that is the involvement. This is the involvement of emphasis 2 substrates. Emphasis on what? 2 substrates. 2 substrates in the sequential mechanism binding, is that okay, to the enzyme, binding to the enzyme before the release of any product. So 2 substrates. All right, so